Hello all. In this video session, we will be discussing about 2D arrays or two-dimensional arrays or matrices. Okay, we will be focusing on declaration of 2D arrays, initialization of 2D arrays, memory representation of 2D arrays, then inserting elements of a 2D array, then displaying 2D array. Okay. Now, what are two-dimensional arrays? Two-dimensional arrays are part of, or they comes under multi-dimensional arrays, and these multi-dimensional arrays are used in scenarios where array of arrays or a collection of arrays are required. So the simplest form of multi-dimensional array is two-dimensional array, and two-dimensional arrays are also called matrices. It is similar to the matrix that you learn in maths. Okay. So first we will see how we can declare 2D arrays. So the syntax for declaring 2D array is, first we have to mention the data type, then array name, then inside square bracket, first square bracket we have to specify the number of rows, and inside the second square bracket we should specify the number of columns. Okay. Now if you want to create a two-dimensional integer array, you can do so by using the statement int, then mat, which is the name of the array, then first square bracket 2, which is the number of rows, and second square bracket 3, which is the number of columns. Okay, so this will actually produce this is the logical representation of the matrix declared here. Okay, so here in our programming language C, the index starts with 0. If you consider the matrix that you learned in maths, there the index will be starting from 1. Okay, that is only one difference. So I will be referring this as row 0 or 0th row, referring this row as row 1 or first row, and I will be specifying this column as column 0 or 0th column, this column as column 1 or first column, and referring this column as column 2 or second column. Okay, now we will see how we can initialize two-dimensional arrays. Okay, so first we will write the declaration as such. We have int mat, then 2 3, which is equal to, inside curly braces, another curly braces is opened, and inside that we will be writing the elements of 0th row separated by comma, that is 0, 1, 2, curly braces closes, then comma, then open curly braces, then again we will be specifying the writing the elements of first row or row 0 separated by comma, which are 3, 4, 5, and curly braces closes, then curly braces closes, semicolon. In the another method, the only difference is that we are not specifying the number of rows, so it is not mandatory to specify the number of rows. Then another method is again int mat 2 of 3 is equal to, inside single curly braces we are writing all the elements of the matrix. Okay, so here the number of columns is 3, so the first 3 elements will be taken as part of row 0, and the next 3 elements will be taken as part of row 1. Okay, and in the next method here it is same as the method above, but the only difference is that here the number of rows is not specified. Okay, so this is the logical representation of matrix initialized here. Okay, now this is actually the logical representation of the matrix. This is not the way actually the memory is, actually these data are stored in memory. So now we will see how these elements are stored in memory. There are two implementations. First one is, it can be stored either in row major order or it can be stored in column major order. Okay, now in row major order, elements are stored in row wise. That is, first elements of row 0 are stored, then elements of row 1 are stored, and after that elements of row 2 are stored, and so on. Okay, so here first elements of row 0 are stored, and after that elements of row 1 are stored. That's why it is called row major order. And in column major order, elements of matrix are stored in column wise. Okay, so first column 0 is stored, then column 1 is stored, and then column 2 is stored, and so on. Okay, if you observe here, column 0 is stored first, then column 1 is stored, then column 2 is stored. Okay. Now next we will see how we can find address of element of a matrix at a particular index. Okay. So first we will see address calculation in row major order representation. Okay. Consider that you have an array A of L1 colon U1, L2 colon U2, where L1 is the lower bound of row and U1 is the upper bound of row, L2 is the lower bound of column, and U2 is the upper bound of column. Okay, they are starting at base address B with size of each element as W. Okay, then the address of element of matrix A at index ij is given by base address plus size of each element into U2 minus L2 plus 1, which is actually the number of columns, into I minus L1 plus j minus L2. Okay. Now for example, we are considering an array A 0 colon 1, 0 colon 2, okay, which is similar to an array that is declared as int A23. Okay. And it is starting at base address 100 and size of 4 bytes per element. Then what will be the address of A of 10? So I have just substituted values for all the variables here and I have calculated the address. Just go through the process. Okay. Now next we will see how address calculation is done in column major order representation. Again, here also the same consideration is taken. Array L1 colon U1, L2 colon U2, base address B, and size of element W. Okay. So here address of element of matrix A at index ij is given by base address plus size of each element into U1 minus L1 plus 1, which is actually the number of rows, into j minus L2 plus I minus L1. Okay. So for example, we have same example as above. We are considering here an array A 0 1 0 colon 2 starting at base address 100 and size of 4 bytes per element. What will be the address of A of 10? So here if I substitute the values, the address I get is 104. Okay. So this is the address I get. Okay. Now if we observe in our array, that is in our normal array declaration in A2 of 3, it will be having lower bound 0 1 in case of rows and 0 colon 2 in case of columns. So in this equation, this will be the number of rows, and here L2 will be 0 and L1 will be 0. Okay. So that is one thing you have to observe. And also another thing is that we have considered the same example in column major order as address calculation, as well as in row major orders address calculation. Okay. And we were finding out the address of A1 of 0. And if you observe here in column major order, I got 104, and in row major order I got 112. Okay. And if you observe in the figure, we can see in row major order address of mat or A1 of 0 is 112, and then address of A1 of 0 in or mat 1 of 0 in column major order representation is 104. Okay. So there will be some difference. Okay. Now next we will see how we can access 2D array elements. Okay, the syntax is array name, then first square bracket we will be specifying the row index, second square bracket we will be specifying the column index. And consider this is the matrix and I want to access element at matrix 0 1. Okay, then that can be done by using mat row index 0 and column index 1. They are actually put inside square bracket. Okay, mat of 0 1 will allow me to access the element here. Okay. And next we will see how we can read elements for 2D array, or how we can insert elements to 2D array. Okay. And in this example here, m is taken as 2 and n is taken as 3. The user has to input the size m and n, where m is the number of rows and n is the number of columns. Okay, so we have two for loops. First for loop is for traversing through the row, and second for loop is for traversing through each element in a row. Okay, then a scanf statement for reading the value, and it is assigned or it is stored in address mat I of j. Okay, so first when this loop starts, initially value of I will be equal to 0. Okay, and 0 is less than 2, so here it will be 1, that is true. And then since it is true, it will go to the inner loop, that is j equal to 0, and then j is less than 3, it is correct, so 1, so it will go inside the scanf statement, and values read and stored at location mat 0 0. Just I am going to store 10 there. Okay, so 10 is stored, and then value of j is incremented, right? Here value of j is incremented, so value of j is incremented to 1. Then after that 1 is less than 3, it is correct, so again it will go inside and come here, and values read at mat 0 1, so I am just going to give mat 0 1 as 20. Okay, then again value of j increments and becomes 2. Now 2 less than n, yes it is correct, so it will go inside this statement, and mat of next value will be stored at mat 0 of 2. I am just going to give 30, and then again j increments and j becomes 3. Now 3 less than 3 is false, so we will go outside, or we'll exit from this inner loop, and then comes here, then I is incremented, I becomes 1. Now 1 less than 2 is true, so again it will go inside this for loop, inside this outer loop, and this statement is executed. Here j is initialized to 0, then 0 less than 3, it is correct, so value is read at location mat 1 of 0. So I'm just going to insert 40 here. Then after that again j is incremented, then j is incremented to 1, then 1 less than 3, it is right, so again it will goes inside the loop body, and again values read at mat 1 of 1. I am just going to put 50 here, and then again j is incremented, and value of j becomes 2. Now 2 less than 3, yes it is correct, so again it goes inside here, and values read at the location, or we will be storing the value at location, or storing the value at address mat 1 2. So I'm just going to store 60 here, and I just stored 60, and then again j is incremented, and j becomes 3. Now 3 less than 3 is not right, so again exiting from this loop and then going here, value of I is 1, it is incremented by 1, so I becomes 2. Now 2 less than 2 is not true, so we will be exiting from this for loop. Okay, so this is how we will be reading elements for a 2D array. Okay, just understand the how we traverse through each element of the matrix. Okay, just understand the concept of these for loops. Okay, now in the next slide we will be seeing how we can display matrix elements. Okay, here also we are considering the size of matrix as m by n, where m is the number of rows, n is the number of columns, and we have already input, or the user has already input the size of the array as well as the elements of the array, and this is the matrix whose value we will be printing. Okay, and this will be the output after each iteration of these loops. Okay, so initially no output, and okay, so initially the value of I is 0, and then 0 less than 2 is actually true. Okay, so it comes inside this inner loop, so j equal to 0, 0 less than 3 is right, so this value will be printed, right? Now if you observe here, I have given printf %d then 2 spaces, right? Then after that it will be printing the value mat of ij. So initially mat of 0 0, 0 0, that is 10 will be printed, and along with that 2 spaces are also printed. Okay, so I just printed that. After that, value of j is incremented to 1. Now 1 is less than 3. Again, the next value, that is mat of 0 1 will be printed. Mat of 0 1 will be printed, that is actually 20, and 20 will be printed with 2 spaces. Okay, now then again j is incremented, j becomes 2. 2 is actually less than 3, so it is true. So again it goes inside and it will print the value mat of 0 2. Okay, that will be actually printing 30. So this value will be printed along with 2 spaces, and after that j is incremented, j becomes 3. 3 less than 3, not true, so it will be exiting from this loop. So the 0th row, execution of 0th row has ended. Okay, so after that we have to print the next row. So before printing the next row, we have to put a new line character, that is we should go to the new line. So this statement will be executed, printf /n, and the cursor will move from here to here. Okay, this is cursor will move to the next line. Then again control comes here, I is incremented and I becomes 1. 1 is less than 2, which is correct. So it will go inside this for loop, and here j is initialized to 0. 0 is less than 3, and then mat of 1 of 0 will be printed, that is 40. So 40 will be printed here. Okay, now after that again j will be incremented, j becomes 1. 1 is less than 3, so again it goes inside this statement. So mat of 1 is printed with 2 spaces. So again 50 is printed with 2 spaces. Here was also 2 spaces, here is also 2 spaces. Okay, then again now the value of j is 1. J is again incremented, j becomes 2. Then 2 is less than 3, it is correct. So again it goes inside this statement and prints mat of 1 2. Okay, so it will be printing 60 with 2 spaces. Okay, 60 and then 2 spaces. Then after that again j is incremented, j becomes 3. 3 less than 3 is actually false, so it will go outside this loop, and again printf /n will be executed. So cursor goes from here to here. Okay, so after executing this statement, control goes to here and I will be incremented. Value of I is 1, so 1 I increments, so I becomes 2. 2 less than 2 is false, so we will be exiting from the loop. Okay, so this is how the matrix will be printed. You should try out this entire program. You should write the entire program and run these programs and try it out to get a better understanding of the code. Okay, now in the next we will be seeing how to find sum of elements of a matrix. Okay, so here also the concept is that we are actually considering a matrix of order m by n, where m is equal to 2 and n is equal to 3. Here initially I have given it as sum is equal to 0. Then this is the matrix whose sum of all the elements are I am actually calculating, and I am just given the iterations of both these loops in this table. Okay, just go through how the value changes and how some are added cumulatively. Okay, then again this we initialize sum equal to 0, then first for loop for traversing through the row and second for loop for traversing through each element in the row, and inside that mat of ij we will get each element of the matrix, and then it is cumulatively added so that we get sum of all the elements. Just go through the iterations and understand the logic of the program. Okay, now this is the sum of main diagonal elements of a matrix. Now in order for a matrix to have diagonal elements, it should be a square matrix, that is m should be equal to n. In a square matrix, number of rows will be equal to number of columns, that is m will be always equal to n. So first we have to check whether m equal to n. If it is true, then we can find out the sum of main diagonal elements. Okay, so this is the main diagonal elements, that is the numbers with blue blue background, and this is called the principal or main diagonal axis. Elements in principal or main diagonal axis is called main diagonal elements, and principal in anti-diagonal axis are called anti-diagonal elements. Okay, so this is anti-diagonal axis and this is main diagonal axis. Okay, so here this for loop, two for loops are for traversing through each element in the matrix, and inside each element we will be checking whether if I equal to j, that is row index and column index equal to 0. In case of main diagonal elements, the row index and column index will be same. Okay, the row index and column index will be same in the case of main diagonal elements. That's why it is given as if I equal to j, equal to j, then add that particular element. Okay, so this is a similar logic, but you can reduce the complexity. You can achieve this by using a single loop as well. Okay, you can try that too. And then after trying out this program, you should also write programs of finding out sum of diagonal elements of a matrix, which will include both main diagonal elements and anti-diagonal elements. Then also try program for finding out sum of two matrices, then product of two matrices, etc. Okay, so you should try out these programs, and if you have any doubt, you can ask me. Okay, thank you then.